Let's look at this problem. A fair coin is flipped 10 times. Find the probability that more than 8 of the flips turn up tails. Okay, so first thing we need to ask ourselves is what model should we use for modeling this probability distribution? And it turns out that the binomial probability model, works out quite well here. We do need to check our assumptions though. So what are the 4 things that you need to check for a binomial probability distribution? Well, the first thing you got to check is, are the trials independent? Well, yes, because every time I flip the coin, that doesn't affect the next outcome. In other words, the last outcome tells me nothing about the next outcome. They're independent from each other. We also need to know that there are only 2 possible outcomes. In this case, that's true. There's only heads or there's tails. There's a fixed number of trials. Yes, indeed, there are only 10 flips of the coin, so we have a fixed number of trials. And last but not least, there is a probability of success that remains fixed throughout all of the trials. And in this case, since it is deemed to be a fair coin, that probability of success is going to be equal to 0.5. Okay, so let's write some of that information down. In particular, we need to know what n was equal to, the fixed number of trials, that's 10. And we need to know the probability of success. The probability of success of seeing a tail, since it's a fair coin, is 1/2 or 50% or 0.5. So that means the probability model that we're going to use is the binomial probability model with n by p being 10 by 0.5. In other words, whenever you write down a binomial probability model, the 2 numbers you need to know are n and you need to know what p is, okay? All right, cool beans. So let's draw ourselves a number line. I always highly recommend when you're doing binomial probability calculations that you write down the situation in terms of a number line. So what do I mean by that? Well, I'm going to put down 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In other words, I'm going to go from 0 to n. So whenever you do one of these number lines, you're going to go from 0. That's always going to be your same starting point, and you're going to come up here to what n is, the number of trials. Now what this number line is this is a number line that represents x. It's the outcomes, the number of successes you saw out of the 10 trials. In other words, 0 means I got no tails, 1 is I got 1 tail, 2 is I got 2 tails, 3, all the way up to I got 10 tails when I flipped the coin. And what they want here, find the probability that more than 8 of the flips turn up tails. So that's the probability of x being what? Greater than or equal to 8. Or you could write it in English, the probability of x being more than 8. If that makes more sense to you, do it that way. Okay. All right, so we're going to need another piece of paper here to get this going. So let's do that real quick. So actually, let's take that back. Let's stay with this piece of paper for a moment first. I'm getting a little ahead of myself. So more than 8. So what would be more than 8? So let's think about that. That would be 8. That would be 9, and that would be 10. In other words, if I know those 3 probabilities right there, then I'll know what the probability of x being more than 8 is. So to find that, what I need to do is find the probability of x being equal to 8 plus the probability of x being equal to 9 plus the probability of x being equal to 10. Okay, I need to add all those 3 probabilities together. Okay, so that's where I'm going to need the new piece of paper. So let's go ahead and get that new piece of paper now, all right? So to do that, get ourselves a clean sheet here. So I'm going to come in, I'm going to calculate, again, remember our model was binomial 10 by 0.5, right? Okay, and I'm going to calculate all 3 of those probabilities and I'm going to add them together. In other words, I'm going to calculate what is the probability of x being equal to 8. Then I'm going to calculate what is the probability of x being equal to 9. And I'm going to calculate the probability of x being equal to 10. And when I take those 3 numbers and I add those all together, I'm going to get the probability of x being greater than or equal to 8. That will be the result of it, okay? All right, so let's get after that because we're going to use the calculator to calculate each one of those, all right? So let's get my calculator up here. And I'm going to show you a shortcut, but let's do it the long way first, and then we'll take a look at the shortcut, okay? So the way the calculator does this, or the way the calculator does these calculations, is it has the formula that's in the book entered into it or written into it. You do not need to use that formula, okay? If you go second vars for distribution and you scroll down to option A here, it takes a bit to get to it, you'll see binom PDF. And binom PDF, what that does is that actually calculates a particular value of a binomial probability distribution, okay? So what that means is that over here, the probability of x being equal to 8, in the parlance of the calculator, or writing it how the calculator would do it, that would be binom PDF, and I need to give it three things. I need to give it, well, let me do it up in general up here first, and then we'll come down and do it for our particular problems. When you do binom PDF, you need to give it back what the number of trials was, the probability of success, and then x, the particular value of x that you're looking for. So remember that this is always n, that's p, and then the x's, you get those from your particular problems that you're working on. So think about PDF P for a particular value. I'm looking for this case for x being equal to 8. So this is going to be 10 by 0.5 by 8. Okay, so let's go ahead and do that. Let's get that number. So if we calculate that, I'm going to hit an enter here. I'm on the newer calculator, which gives me a menu-driven system. On the older calculators, it will just put up binom PDF, and you got to put in these numbers. Okay, so I'm going to put in a 10. Put in my probability of success, which is 0.5. Put in my number of trials, which is 8. Come in, and it pastes that command onto the screen. Now I can hit an enter, and it'll give you back the number, okay? So it looks like that number is going to be, if we take and write that number down to, let's go out 4 places here, that's going to be approximately equal to 0.0439. I'm going to go out 5 places. Let's go out to 9.5, okay? You'll see why we want to go out to 9 places in a bit. Okay, all right, so let's pick up the pace here a little bit. So this one is going to be what? This is going to be binom PDF. Number of trials again is 10, and then 0.5. But this time we're going to use a 9, okay? All right, so how do I get the calculator to do that? Well, you can go back in second, distributions. If you hit the up arrow, it's a little faster to get to it. It's not quite as many clicks that you got to do to get to it. Go to binom PDF. And then this time I'm going to put in 10. And then I'm going to put in 0.5. And then I'm going to put in what? 9, right? Paste that command to the home screen. Hit an error, and I get 0.00977. Okay, so this is going to be equal to what? Let's get my calculator up there. I like to see what I'm doing here. Okay, so that's going to be equal to 0.00977. Okay, if we go out 5 places. All right, one last one that we need to do. What is the probability of x being equal to 10? So what's that going to be? Let's write that out first. So that's going to be what? Binom PDF, going to be 10 by 0.5 by 10, okay? And so let's go get what that's going to be. Let's go second, distributions, go grab, oh, silly machine, there we go, grab binom PDF. It's going to be 10 by 0.5 by 10. Paste that command, hit an enter. And notice that it goes E-4, which means that I got to move this decimal place 4 places to the left, okay? So we're only going to get one non-zero digit in this last one. In other words, this is going to be 0. Let's see, I moved it over what? 1, 2, 3, 4 places. So that means I got to put in some leading zeros, don't I, right? So let's see, if I round this off correctly, that's my rounding digit right there. This is going to bump out to 0, 0, 1, 0. If I take it out, let's see, 1, 2, 3. Let's see, wait. I count 1, 2, 3, 4. I was going out 5 places. My bad. Never mind. Hang on. I know how to count, really. I do. Okay, 9, 8. There we go. Okay, I rounded off correctly. So if I take it out, get the right number of zeros in there. If I take it out to 5 places, that's what it's going to look like. Okay, here, let me go clean up my calculator. Let's get rid of this mess off of there. Let's go get my large eraser here. Why are you not staying on the eraser? Oh, that's a silly thing. Okay, never mind. All right, now I need to go in. I need to add up all of these numbers together. Okay, I'm going to let you do that part. Okay, if you don't mind, I'll let you come in to take that number plus that number plus that number. Okay, and I'll let you see what you get. Because I want to show you a shortcut here. I want to go move on just a little bit and show you a faster way of doing this. So another way of doing this problem, let's go back to our number line for a moment, is to think a little bit about what we learned about probabilities back in chapter 2. This is where the number line comes in really handy when you're working these problems. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and once you see this, you're going to realize that the way I did it before is really the hard way of doing it, and you don't want to do it that way. This is the way I'm going to show you now is much, much simpler. Okay, so what are we looking for? We want the probability of x being greater than or equal to 8. So again, come in and put those dots in front of those values on your number line that represent the situation at hand. In other words, the x is greater than or equal to 8. Okay, but while I'm at it, I'm coming here and change my pen. And let me show you all these guys over here. All right, so all these red ones, what those red ones are, those are the probabilities of x being less than or equal to 7, aren't they? In other words, that's 7, 6, 5, 4, 3, 2, 1. So it's counting down that way. Now, if I take these two probabilities and I add those together, in other words, I add the red ones to the blue ones, that has to add up to 1, doesn't it? Okay. It's one of the requirements to be a probability distribution is that if you take all of the possible items in the distribution, calculate all their probabilities, add them all together, it has to add up to 100%. It has to add up to the totality of everything that could happen. Okay. Now here's the deal. The calculator has a built-in function for calculating this red piece right here. It knows how to do that. It knows to sum from the left up to the endpoint that you pick using a command called binom CDF. So if you use binom CDF, C for cumulative, let's make that look like a U. Cumulative, okay? Cumulative is an additive, okay, into adding things up. So what the binom CDF does, again, it uses n. You got to put that in there. You got to put in p as the probability of success, and then you put in x. But this x is a very different critter this time. This x is the right endpoint. It's the right endpoint of the sum. So that means it adds up 0, 1, 2, 3, 4, 5, 6, and 7, all of their individual probabilities. Probability of x being equal to 0, equal to 1, equal to 2, etc. Okay? Now, what's the big fat hairy deal that? That's not what I want. I want the probability of x being greater than or equal to 8. Well, here's the trick of it. Okay? What we know is, by using a little bit of arithmetic here, is the probability of x being greater than or equal to 8 will be equal to 1 minus the probability of x being less than or equal to 7. In other words, if I calculate the probability of x being less than or equal to 7 using binom CDF and subtract that from 1, it's going to give me my desired probability. So in other words, let's write that down. In other words, let's put that in calculator command language, so hopefully it'll make sense. So this is going to be equal to 1 minus binom CDF. And let's see, what was n again? Well, n was equal to 10. What was the probability of success? Well, that's 0.5 because it's a fair coin, right? And what was my right endpoint of my sum? Well, it's 7. Okay, so let's go take a look and let's see if we got the same number that you got doing it the hard way a minute ago, adding up those numbers for me. So I'm going to go second distribution. Again, shortcut is to hit the up arrow to get to it because it's option B here. Ah, wait, got a little ahead of myself. Get out of here, second quit. We can't do it that way. Got to get my 1 minus in first. I always do that. And you'll find, hopefully, you're not as bad as me and you remember to do that first. You got to put the 1 minus in first, then go do the second. binom. Okay, so binom CDF, put in the 10, put in a comma, put in a 0.5. Oh, we don't need the comma like I'm in the fancy calculator. Sorry about that. I keep switching back and forth between two different calculators since I forget which one I'm on sometimes. So there we go. 0.5, and the probability of success being the 0.5, and the x being the x value. What is the right endpoint of our sum? That's a 7. Let's go paste that command in, and notice now I have 1 minus binom CDF, etc. And an enter, and that should look very close to the number you got a minute ago, adding up those three numbers. Now, once you get the hang of this, this is way faster and a whole lot more efficient than adding up individual probabilities. If you have a lot of them, what if you had to add up all 7 of those probabilities? That would be horrendous having to calculate all those numbers, okay? So you're much better off learning how to use this command, in particular, learning how to use the complement rule. Okay, well, hopefully that helps. If you need any further help with it, do not be shy about asking for help, okay?